Well, this is a kind of prototype of a generic set of problems that worldwide technology now brings before us. A set of problems which involve unanticipated negative consequences of apparently benign technology, consequences very severe, consequences that are global in nature, and therefore that cannot be solved even by one or two of the most powerful industrial nations by themselves. It requires the entire industrial world to deal with. Let me give another example. We talked about the visible part of the spectrum and the infrared, longward of red, while going the other way, shortward of violet. There's another part of the spectrum that the sun puts out, that every object puts out, but that our eyes are not sensitive to, called the ultraviolet. Ultraviolet light is very dangerous because the molecules that make us up, especially the nucleic acids and the proteins, fall to pieces or undergo chemical reactions when exposed to ultraviolet light. We ordinarily don't have to worry about that because we have an ozone layer. Ozone is 3 atoms of oxygen, chemically bound, that a kind providence has put up 25 kilometers to 40 kilometers in the sky, and it absorbs almost all of that ultraviolet radiation. There's very little ozone, however, up there. We're brought down to this room, the thickness of the ozone layer would be 1/4 of a millimeter thick. It's small, therefore it's vulnerable. Now, in refrigerants and decreasingly in aerosol propellants, and as a degradation product of some plastic, styrofoam, and the like, is a set of molecules called chlorofluorocarbons, CCFs. The brand name of the most widely known is a DuPont brand name, Freon. These molecules have been chosen precisely because of how chemically inert they are. No harm if you breathe them. They don't interact with anything around here. It sounds like the ideal kind of byproduct for some industrial applications. But precisely because they're so inert, they stay around for a long time. They get out into the open air. The atmosphere circulates them. And eventually, they wind up high in the atmosphere, where they bump into ozone molecules, and ozone is sufficiently reactive to combine with the CCFs and fall to pieces. Well, what is happening is that the ozone is declining. There is a unpredicted and extremely worrisome hole of large dimensions in the Antarctic ozonosphere. There are other holes in the ozone which are appearing now in Spitsbergen and elsewhere. And it seems very clear that the production of chlorofluorocarbons is in the process of compromising the global ozone layer. And the time scale for these molecules to be scavenged out of the atmosphere, in part by interaction with ozone, is something like a century. So if we stopped right now all ozone, all CCF production, 100 years from now, the consequences would be apparent. Now, what would happen if there was a significant decrease in the ozonosphere? A superficial consequence, which is what one mainly hears about, but it's by no means the most worrisome, is an increase of skin cancer in people with light skins. People with dark skins are better protected. This is one of the few cases where there's a kind of technological justice. The people who do the technology carelessly are the ones who are preferentially destroyed by it, and dark-skinned people who didn't do it are not bothered by it. In most cases, it goes the other way, that the people who had nothing to do with the technology are the ones who most suffer from the negative consequences. But much more important than skin cancer is the fact that there's a vast range of microorganisms that are exquisitely sensitive to increased ultraviolet light. For example, the phytoplankton at the surface of the oceans, which are the primary source of molecular oxygen in the Earth's atmosphere. There is a vast ecological pyramid. You know, these guys harvest sunlight, and then these guys eat those guys, and these guys eat those guys, and way up at the top, that's us. We eat them, who eat them, who eat them, who eat them, who eat these guys who are sensitive to ultraviolet light. Now, this web of interactions is extremely poorly studied, extremely poorly understood, but I don't think it's being alarmist to say that there's something to worry about here. And to try to deal with this issue, large number of industrialized nations, United States and Canada, Western Europe, the Soviet Union, Japan, have been meeting and have agreed in principle on emission controls of chlorofluorocarbons. There are special cases. Soviet Union and Japan want some exclusions for periods of time so as not to harm their domestic industry. Some U.S. corporations have been very responsible on this issue, even if it involves some loss of profit. But this is another example of an accidental byproduct of high technology that has global venue, that involves all industrialized nations, that has possibly extremely serious consequences. And there are others. Acid rain, for example, radioactivity from nuclear reactor accidents. One very worrisome aspect, though, is if you look how these dangers were uncovered, they were uncovered absolutely accidentally in the byproduct of some other kinds of scientific investigation, and very late, which suggests that there is probably a significant category of other serious global consequences of technology that we haven't been smart enough to figure out yet. Other discoveries along these lines will be made in the future. We could even describe some epidemic diseases like AIDS as in this category, because they clearly are significantly assisted by advances in transportation technology, so that the world is, to a significant extent, a sexually intercommunicating whole. And the exponentiation of the number of AIDS cases worldwide is now something very serious, because exponentials beat everything. And this may very well have powerful consequences in the distribution of power worldwide. For example, Soviet Union and China have disproportionately extremely small incidence of AIDS, because they are not as sexually intercommunicating with the rest of the world as many other countries. It is possible that one consequence of the AIDS epidemic is to leave the Soviet Union and China in a disproportionately better off situation than the industrialized West and Japan. That might be the single most significant determinant of the balance of power among nations on the planet, and not economics, not nuclear war, not anything else. And who would have figured that? Well, I want to say a few words about the nuclear arms race. It is, in a way, in this category as well. And one way to look at it is the following. In 1945, just after when Lester began with Bretton Woods, The United States was the most powerful nation on the planet, not just economically, but militarily. It was invulnerable. Surrounded east and west by impassable oceans, north and south by weak and friendly neighbors, the United States had absolutely nothing to worry about in a military sense, at least in terms of direct aggression by other nations. The United States then developed nuclear weapons and their delivery systems, has been the leading nation on the planet in ever increasing the sophistication of these weapons and their delivery systems at enormous cost. I'll say something about cost in a moment. And driving, I think there's no doubt that it's American technology that has driven the nuclear arms race much more than Soviet technological advances. Soviets are always in the situation of huffing and puffing to follow up and try to match or counter American advances. And the net result is that today, the United States is exquisitely vulnerable to utter annihilation because of the very technology that the United States pioneered in the development of nuclear weapons. We are alive in the United States today because Soviet leaders did not 20 minutes ago decide to annihilate us. And Soviet citizens are alive today because 20 minutes ago, American leaders did not decide to annihilate them. Everybody in the United States is vulnerable in extremely short timescales, a fuse 20 minutes long, because of this technology designed to protect ourselves. There is a kind of irony. Now, the nuclear arms race is so invested with national propaganda on both sides that, of course, both sides have a list as long as your arm of the abuses by the other and all the reasons why it's essential to have nuclear weapons to protect ourselves. But the net result is that nobody is protected and everybody is vulnerable. There are some 60,000 nuclear weapons in the world. The planet has been booby-trapped by the United States and the Soviet Union. Of those 60,000 weapons, almost 25,000 are so-called strategic weapons, that is, connected to delivery systems that carry them from the homeland of one superpower to the homeland of the other superpower, and the remaining 30 to 35,000 nuclear weapons are so-called tactical nuclear weapons, some of which are given demeaning names like munitions, but most of which are more powerful than the bombs that destroyed Hiroshima and Nagasaki. How many cities are there on the planet Earth? There's about 2,300 cities, if you define a city as having more than 100,000 people. That means that the United States and the Soviet Union, if they wished to cooperate on this matter, by devoting 2 nuclear weapons to every city on the planet, could destroy every city on the planet and have 20,000 strategic weapons left over as a challenge to the targeteers to figure out what to use those weapons for. I think it's very clear that no matter what the function of nuclear weapons are, there are far too many of them. In a so-called central exchange between the United States and the Soviet Union, estimates of the prompt fatalities, that is, in a few days to a few weeks, range from many hundreds of millions to a high estimate by the World Health Organization of about 2 billion people killed outright. And that's mainly from blast, fire, prompt radiation, and short-term radioactive fallout. There are a set of longer-term adverse consequences of nuclear war. And let me just list a few of them. There's long-term radioactivity, which spreads most of it hemispheric-wide, northern hemisphere. There's a northern mid-latitude target zone where the greatest vulnerability is, but the radioactivity spreads north and south of that. And some of it, we now know, spreads into the southern hemisphere. There is a new and very incompletely understood consequence from the burning of modern cities, the production of toxic smogs. You know how in the burning of a modern skyscraper, people are said to be overcome by smoke. Smoke inhalation is what it's called. That's not what happens at all. What happens is that in the burning of modern synthetics and plastics, a witch's brew of poison gases is generated. Carbon monoxide, dioxins, furans, and you breathe them, and it's like gas warfare, and you are poisoned. Now, in the burning of a modern city, those gases, all heavy, so they stay near the ground, spread out from the city into the surrounding countryside. And some estimates of how much of that would occur are very serious. This is not something that the defense establishments have discovered, and it's not something that they're interested in calculating. It's all been done by civilian scientists. And then there are a set of extremely serious climatic consequences which go under the rubric of nuclear winter, which is essentially a blocking of sunlight for periods between weeks and perhaps years, lowering of temperatures, 10 to 20 degrees centigrade change in the average temperature of the planet are what the range of modern calculations for a nuclear war that involves about a third of the strategic arsenals. The average temperature difference between now and the last ice age is 10 degrees centigrade. So we're talking about very serious temperature changes. The most significant adverse consequence of nuclear winter is in agriculture. The destruction of crops. For example, Canadian wheat and barley production is brought to zero by a 3 degree centigrade temperature decline. And it is estimated that from this source alone, starvation for several billion people is likely. There are also a range of synergisms, that is, cases where the sum of the where the net adverse consequence is more than the sum of the individual adverse consequences. And let me give just one example of how that would work. The prompt effects of the nuclear war destroy doctors and hospitals who are preferentially in the target zones and in the cities. The destruction of civil and sanitary facilities promotes the development of disease. Birds are preferentially killed by lowering temperatures and the radiation. They are a significant source of control of insects, which are disease vectors. So the birds aren't there. The disease carriers proliferate. Medical facilities are unavailable. And radiation levels that aren't enough to kill you are enough to significantly lower your immunity to disease. And one of the consequences of the sub-lethal radiation in a nuclear war, even in places far from target zones, is something like a global case of AIDS. That is, I mean, you don't have to do anything special to get it, except be complacent about the nuclear arms race. But what happens is your ability to resist disease is compromised at precisely the time when diseases are rampaging. That's an example of synergisms.